Welcome, ladies and gentlemen, to our joint webinar, MYPV and Huawei. We are presenting our solutions together, and we are going to focus on the combination of our solutions. For you, it means that you can create more benefit out of the combination of our two brands. And together with me in the webinar room is Dieter Jauch, my colleague from Huawei Germany. And my name is Reinhard Hofstetter. I'm from MYPV here in Austria. And Huawei, I think, is famous for its business. It's today about the inverter side. What MYPV does needs probably to be explained a little bit. We are a manufacturer of power-to-heat applications. So hot water heating with excess PV power in residential systems is our business. And our solutions can work together with Huawei inverters. And this is what we are going to tell you today. So welcome. And I would like to start with a short introduction. My name is Reinhard Hofstetter. I'm at MYPV since 2016 now, and I'm responsible for product management. There are these two gentlemen over me on this slide. The gentleman on the top is Dr. Gerhard Rimpler, our founder and managing director. And Gerhard founded MYPV 10 years ago, and his core know-how is the solar electronics side, while my business is the thermal side. So before I started at MYPV, I was in R&D of solar thermal systems. And from that point of view, I know pretty much about pipes and thermal collector systems and expansion vessels and pumps and all that stuff. And from this point of view, we are aware at MYPV that this old-fashioned traditional way of creating heat from the sun is not up to date anymore. Today we have photovoltaic power, and wires instead of pipes can create heat out of solar electricity more efficient and much easier than this old technology that we had with the solar thermal collector systems. The gentleman in between is Talal Bat, our international sales manager. Talal is now also available for your questions in the chat. So while I'm talking, you can send him questions anytime, and Talal will answer these questions during our presentation. Latest milestone in the young history of MYPV is the new company building. We have created the base for our further development, for our further improvement of sales, let's say it this way. When we started 10 years ago with the idea which was called hot water from PV, this was pretty much ahead of its time, to be honest. But nowadays, this really made it to the hearts and minds of the people. And with this company building, we have done the base, we have created the base for our further market development. All right, so enough from my side. I'm finished with my introduction. Now it's the first time where I can hand over the presentation to Dieter Jauch. We are switching the presentation roles 2 times during the presentation, and now it's about Dieter to introduce him and Huawei.
Yeah, thank you very much from you, Reinhard. So my name is Dieter Jauch. I'm a solution manager for the residential portfolio from Huawei. And I want to show you our products. They work together with MYPV products. And yeah, so this is a nice picture of one combination. I want to say some words about the company or some important numbers. We have nearly 200,000 employees around the world. And what is very interesting that more of the half the employees are working in R&D. That means research and development. They searching for new solutions, searching for new products, and this is very interesting. And also, the around the world, we are delivering our products to more than 170 countries, and this is very interesting. And yeah, what's also very interesting that we have different R&D centers around the world. One is also in Germany. It's in Nuremberg, where I'm also based. So this is the power electronics Silicon Valley R&D department. So they are searching for new solutions for inverter or energy storage or energy transforming. And normally they are working in the future. So when you ask these guys, so they can tell you what kind of products or parts of the products will come in the next 3 to 5 years. So what is very important that we have not only in China developing from products, also around the world and also in Germany. And also one of our first products was pre-developed in the German R&D center. Okay, that's from my side, and then I want to over to you, Reinhard, and then you can tell more about the four-person household.
Yeah, actually, it's about the energy demand in a four-person household, and one segment of this demand is very important to us. So this is the one we are focusing on. Most of the people know how much electricity they need per year for their electric appliances. So let's say the light and the devices like washing machine and TV and so on. And for a single family household in Europe, this is a number of roughly 4,000 kilowatt hours. This is electricity for electric appliances. And most of the people are aware that they use that amount of energy, but hardly no one knows that we are using nearly the same amount of energy for hot water heating. And this is the topic from MYPV, power to heat in residential systems. And this means basically hot water heating. And for an energy demand of 4,000 kilowatt hours per year, photovoltaics enables us to cover this energy segment to the most part of the year. Not completely, but the main part can be covered with excessive PV power, so energy that usually would be fed into the grid. And this is the application we are famous for, hot water heating from PV power. A newer topic, a younger topic at MYPV is electric space heating with PV power. I'm not going into that much into this too much today, but for this application, it's very important to look on the energy demand of the building. It's completely the wrong application for old buildings with a huge energy demand for space heating. But for newer buildings, I'm thinking about the new single-family home that I'm going to build today, for example, or this year. It is possible to install the whole space heating system purely electric and cover this energy demand with PV power to the most part of the year as well. So a younger topic, a special one, I would like to deal with hot water heating from PV power. This is our main usage. We are using electric heating elements, direct electric heating elements. So it's not about heat pumps. And when people think about electric heating elements, they usually think about this principle on the top here. They think that we are using the energy from the public grid one by one. They think it's not efficient, it's not eco-friendly, it's not cheap. And luckily, this is not the way we are working. Our principle, MYPV's principle for power to heat, is shown in the lower picture. So we are using excessive power from the photovoltaic system, and we are using it for heating, for electric heating. This is what it's all about. So the energy comes from your own roof. It's eco-friendly, it's cheap, and it's sustainable. This is the difference. And there's an option for all MYPV products. We call it the optional boost backup mode. So if you like, you can cover the rest of your energy demand with electricity from the public grid. I'm thinking about the winter month, December, January, when we do not have enough power from the PV system. We can take the backup from the public grid, but only if you like. The factory preset is that this function is always deactivated, but if you use it, it gives you the chance to shut down your conventional space heating system during summertime. You save on the lifespan of this conventional space heating system, and we usually have a very huge solar coverage ratio of the heating appliances respective of hot water during summer. So there are just a few kilowatt hours backup required for those days, let's say when there are 2 or 3 days with bad weather condition. But it's an option. The factory preset is that this is deactivated here, and you can always combine our solution with other thermal heat sources. So it does not matter to us if the hot water boiler or the storage tank is fed by a gas boiler, a heat pump, a district heating system as well beside the MYPV solution. It's absolutely no problem. It does not matter if there is someone else who's feeding the same thermal tank. Okay, let's talk about storage capacities. The most common form to store PV power is, of course, the battery. Why? Of course, we have electric power from the roof and we want to store it in an electrical storage medium. Typical storage capacities in single-family homes are somewhere around 5 to 10 kilowatt hours. And this is a relatively low storage capacity, which is up today still pretty expensive in comparison to a power-to-heat application. So as a cheaper alternative, you can use your hot water boiler, for example, to heat it up with excessive PV power. This storage capacity, respective the tank or the boiler, is usually available everywhere where people are living, and it just needs a very low investment with a MYPV solution to make use of the storage capacity for PV power. So we can either be a cheaper alternative to battery, that's clear, but I want to say it very clear, we do not compete with batteries. For the combination with Huawei, it's possible to have both storage medias. So if there is a battery, we charge up the battery first, and after the battery charging is completed, then we use the rest of the excessive energy for thermal applications. So MYPV is making use of the rest of the excessive power. It's about self-utilization ratio. And here is a diagram from a German university, and it's very well described what effect it has to use this or that storage medium for the self-utilization ratio in a single family home. Let's talk about one example, a 5 kilowatt peak system on a single family home. So for Central European conditions, you usually have a self-utilization ratio in this system of approximately 30%. That's not much, and the rest of the energy, the rest of the 70%, is fed into the power grid. It's clear why, because the production on your roof does not happen at the same time when you have demand for electricity in the building. First way to improve the self-utilization ratio is install a battery. With Huawei, it's no problem, and you can increase your self-utilization ratio to nearly 2/3. This is the common way, no problem with Huawei. But as a cheaper alternative to the battery, we are offering a power-to-heat system from MYPV, from us. And see there, we increase the self-utilization ratio even higher at lower investment. But again, to be clear, we do not compete with the battery. I have no doubt battery systems are a very important base for the transition to renewable energies worldwide. And for the combination with Huawei, it's possible to use both storage capacities combined. And if you do so, you increase your self-utilization ratio to an absolute maximum of over 90% in this example. If there is a battery, then the charging of the battery should have priority for the hot water heating by MYPV. Why? It's very easy. if we have created heat out of this excessive energy, we cannot get back electricity out from the storage tank. So the value of electricity is higher in terms of economics and in terms of physics, and power to heat should always be the last application before we feed into the power grid. But in Europe, we are now going into springtime, and the days are becoming longer again. And what we see in the next few weeks is that common storage capacities, battery capacities, are completely used to an SOC of 100% sometime in the early morning, in the later morning, sorry. And from this moment forward, we can make use of the excess energy with power to heat because the battery is already fully loaded. Good. So it's about excessive power. It's about energy that usually would be fed into the power grid, and this might not be interesting, for example, because of economic issues. There is probably not an interesting tariff for the fed-in kilowatt hour. So let's make use of this energy in the building. Let's make heat out of this energy. So when we have a PV system on the roof, the next priority for the use of the electricity of the PV power are the normal households. This is the normal way it works. And if all house loads are supplied, then the rest of the excessive energy goes to the battery storage. And when the excessive power exceeds the maximum charging power of the battery, we can make use of the rest of the power. And this also applies when the battery is full, or as I mentioned, when the excessive power exceeds the maximum charging power of the battery. So in the feed-in point, Huawei is metering this amount of excessive power, and we are getting this information from the Huawei inverter. So it's not only about the Huawei inverter, there has to be a meter in the feed-in point as well, and we receive this info, which is the only info that matters to us, and make use of it by power to heat. And there are two ways to use the excessive PV power for heating. Number one is a product here in the background at my place here, which is called AC ELWA-E. The abbreviation ELWA means electric water heater. AC describes that it's a solution for alternating current, of course, and E stands for Ethernet, for LAN, local area network. We are getting the excessive power information from the Huawei inverter via the local area network. So there's an RG45 Ethernet socket at the bottom of the box here. And when you look at this solution a little more closely, you see that this is an immersion heater. Basically, the heating rod here is an immersion heater. So the question comes, what is special about this immersion heater? What is special about it is the chance to control the power output, the thermal power output, linearly. And to do so, we need the core know-how from MYPV. There's a power stage in this green box here, which adjusts the thermal power output on this heating rod. The heating rod itself is 47 centimeters long, and there is a 1.5-inch connection thread. This is a very common thread, which can be found on most hot water boilers or storage tanks. And inside this tank, there is the immersion rod, the immersion heater, the heating rod, and it's assembled in the storage tank. What is on the outside of the tank is this green box, which contains the power stage, the core know-how from MYPV. So we make this immersion heater linearly power controlled, and thus we make it, let's say, PV ready. Only a really linearly controlled thermal power output is a power output which is PV ready, because there are two things that are changing permanently. The solar yield, the PV yield, is changing permanently. Why is clear? There are clouds moving on the sky and the solar irradiation changes during the day. But there is a second thing as well, and this thing are the loads in the building. So some appliances are always switched on and off, and what changes as well is the energy demand in your building. And what it's all about for our immersion heater is the difference. It's the balance in the feeding point, what we want to make. So if the Huawei inverter tells us that we have 3 kilowatt excessive power, we making use of all 3 kilowatts. If it's telling us in the 1 second later we have excessive power of 2566 watts, we are adjusting our power output accordingly. And this happens very fast and very accurate with Huawei. So if you just switch on the light here in the living room, you have less excessive power available, and the AC ELWA-E immediately reduces its power output to ensure the balance in the feeding point again. We ensure that there is no feeding into the grid and no input from the grid. All right, and this works with Huawei with or without battery. This is the good news, and there are the specs for the AC ELWA-E. And we are going to supply or to provide the slides of the webinar after the session. So we are not going into every detail here of the specs, but what I want to mention is our way of doing the linear power control. So between 0 watts and 3000 watts, each single watt can be adjusted on the heating rod. And we are doing this not by using a thyristor. Basically, our power stage works like the power stage in a PV inverter. So we are compliant with the rules of the grid operator in Austria here, in Germany as well, but also in Switzerland, for example, where the rules of the grid operators are very strict. Communication, already mentioned, Modbus TCP, respective Ethernet or local area network, is the way how we get the excessive power information from the inverter. All right, there is another solution from MYPV which can be combined with Huawei. So imagine that you already have an immersion heater in your tank and you do not want to disassemble this immersion heater. It should be reused for the future as well. So it's some kind of retrofitting which you want to achieve. This is not possible with the AC ELWA-E because the heating rod is fixed combined with the power stage in the green box here. So advantage comes with the ACHTHOR. Instead of the heating rod, there is a socket on the bottom of the device, and into this socket you can plug a standard immersion heater. So it can be from a third-party company. If it's a 3 kilowatt immersion heater or lower, you can just plug it in and ready. And then the ACHTHOR is the, let's say, the gearbox in between the PV system and the immersion heater, which makes this PV immersion heater linearly power controlled, respective. It makes this immersion heater PV ready. Why is something that I already described on the last slide with the building. So it's basically the same principle as with AC ELWA-E. It's not some kind of smart home system. Both solutions are AC power stages to adjust the power output. One comes with an immersion heater and one comes with the socket. The one with the socket, the ACHTHOR, as we pronounce it, gives you a maximum of flexibility. So here it is in more detail. It has a European socket on the bottom for a 3 kilowatt load, maximum 3 kilowatt load. It does not need to be an immersion heater. It also works with an infrared panel or with an electric heating mat. And for the international market, the ACHTHOR comes with an adapter for this European socket. So you can wire your electric load yourself. And if the ACHTHOR is installed in a way as we see it on the right side of this slide here, which means over this cable box here, then all the cables and all the wires disappear, and this looks very good from our point of view, and this is the way we want to recommend to install it. Okay, it has many unique sales points. One is the very compact size. It's really small for a 3 kilowatt power stage, and there is also a display which gives you the chance to to do settings very intuitive. So it's not necessary to read the manual, for example, if you want to adjust the optional boost backup mode to ensure a minimum temperature. It's really self-describing, and you can go through this very easily. Then there is everything pluggable. Unique sales point number 3, unique sales point number 4. We are open for third-party control, so there is a MYPV power meter to detect the excessive power in the feed-in point available from our side, but you do not need these accessory parts for the combination with Huawei. We can make use out of the signals which are provided to us by the Huawei inverter. So third-party control, which is the base for our successful cooperation with Huawei. And there are two technical ways to combine the ACHTHOR with the Huawei inverter. One is Modbus TCP, respective Ethernet, and this is the same way to communicate with the Huawei inverter as we already described it for the AC ELWA-E. So it's a communication via LAN, local area network. For the ACHTHOR, there is another way to combine it. It's RS485 or Modbus RTU, as you might call it. But this is not the one I want to recommend to you. It works very well. We already have done reference projects with this way of communication. But doing the communication via Ethernet gives you more benefits. So with the communication via Ethernet, for example, you can also combine it with a battery system then. This is not recommended with the RTU communication, but it's possible, and to make the info for you complete, I have mentioned it now. The ACHTHOR has also something that we are calling the big brother of the power stage, and it's not a mistake from our side that we are making use of the same image here on the right side of the slides. This is really now a 3-phase 9 kilowatt power stage. So with the single phase version it was a 3 kilowatt power stage, and now it's a 9 kilowatt power stage in the same box. And this is now an energy density that is really unique on the market, and we are really proud of it. And what is still done is the principle that everything here is pluggable on the bottom. All right, what is very interesting on the ACHTHOR 9S, as we call it? All 3 outputs are controllable, which means we can adjust the linear power output not just on one phase. We can change the linear power output from phase 1 to phase 2 to phase 3. So this is unique. Our competitors on the market, they are only working in a way to control the power output on one phase, and if there is excessive power available or enough excessive power, they are just switching phase 2 and phase 3, but it's just switched, and the linear power control just happens on phase 1. So we are better in that way. We can adjust the control phase to each one of these 3 outputs. We can do the linear power control on each output, not simultaneously, but one after the other is possible. And this gives you the chance to provide, let's say, not just a 3-phase load with excessive PV power. We can also provide this excessive power to 3 single-phase loads, for example. One important tip for retrofitting, if you want to make use of an existing 3-phase immersion heater, then please check out one detail. We need a neutral conductor on this immersion heater. We are connected to the load. How is it called in English? We have a star connection and not a delta connection. This is the way to describe it. Yeah, ACHTHOR and ACHTHOR 9S advantages. If you want to go through that list, you can do this easily after the presentation at any time. We are going to provide the slides, as I mentioned. I'm not going into every detail here. For those of you who want to be sure that all the components fit together, there are also accessory parts available. So a 3 kilowatt single phase immersion heater for the ACHTHOR or a 9 kilowatt 3-phase immersion heater for the ACHTHOR 9S is optionally available from our side. But to be very honest, it also works with third-party immersion heaters. Okay, and there's our reference project. There is the inverter from Huawei, and on this inverter, there is also a meter connected, which is installed in the feed-in point of the building. And there we get the required information to do our work. It's all about excessive PV power in the building. So when this picture was made, the installation was not yet finished, but the cover here is missing. But now it's of course there, and it looks very nice as the installation with the Huawei inverter on the left. It's a single family home. There's a 10 kilowatt peak PV system, and with our ACHTHOR mode 1, we can make use of 9 kilowatt excessive power, if this excessive power is available. And this 9 kilowatt immersion heater is installed in a storage tank with a volume of 1000 liters. The communication works via Modbus RTU, so not via network. But again, Dieter and I, we strongly want to recommend LAN communication to you, because it gives you the benefit to install a battery system from Huawei as well. It gives you the benefit to have cloud access from MYPV to the ACHTHOR. And yeah, this is not the case when these two components are just communicating with each other via Modbus RTU. So LAN is strongly recommended here. Okay, so how can the settings be made on MyPV to communicate with Huawei? There are two manuals, one for the ACHTHOR, one for the AC ELWA-E. And for both solutions, it's basically the same when you do it via Modbus TCP manual. For RTU, there's the way to do this with 3 wires, A, ground, and B. And here are the pins where this needs to be connected on the ACHTHOR. And on the right, we have a bottom view of a Huawei inverter, but this is just an example. It depends on the inverter type where this RTU communication needs to be connected. I'm saying it once again, we recommend the LAN communication to you. So if you choose Modbus TCP, you can either do this on the web setup. It completely looks the same for both solutions. Does not matter if it's AC ELWA-E or ACHTHOR. The web setup always looks the same. And here you can choose Modbus TCP manual. Then all configurations, all settings are pre-configured for you. We already have done this in our firmware. There is just one thing that needs to be adjusted beside the communication type. It's the IP address of the inverter. And therefore, I want to recommend to set static IP addresses in your system. Very important to do this for the inverter, because let's think about a short grid blackout. And when the power comes again, the router in the building restarts, and then it probably reassigns new IP addresses to its network clients. And from this moment forward, we would lose our communication signal, because we have set a static IP address here for the communication with Huawei. So if you set a static IP address on the inverter as well, then we are always reconnecting the communication even after a blackout. So for AC ELWA-E, there is no display on the solution, and this setting needs to be done in the web setup every time. For the ACHTHOR, there is another alternative. You can do the settings on the display as well. Choose the communication type, either RTU, then you are finished with the settings here, but Modbus TCP is recommended, and then the control IP can be set on the display as well. All right. Dieter, somehow you dropped out of the webinar room while I was talking, but good to see you back again. Now it's your turn.
Thank you. Yes, I have a little bit a weak internet connection and not a static IP, maybe.
Probably.
No, yeah, very good. Do you see the questions in the chat, or maybe you answer also this question in the chat in my missing time about this separate metering of each phase? But I think you answer this question,
Yep.
or maybe you make it now. Okay, from my side, yes, there are two main products for the residential portfolio. We have on the left side the single phase inverter, on the right side our three-phase inverter. So what is very important is both inverter are hybrid inverters. So since 2 or 3 years, Huawei don't produce this DC to AC inverter anymore. These two inverters are always hybrid inverters, so they are battery ready and you easily can connect our own battery. So this is very important. And what is also very important, that we need a communication interface to MYPV, and our communication interface is our smart dongle. For the three-phase inverter, our smart dongle is inside of the box of the inverter. And for the single-phase inverter, it's a little bit special. So the single-phase inverter has a built-in Wi-Fi interface, but this interface don't support Modbus TCP. So that means you need an extra dongle for Modbus TCP communication. This is very important. Optional, you can also add a 4G dongle, but with this dongle, yes, you have 4G for communication with our portal, but you have no local communication interface. So that means the best way is to use the normally Wi-Fi fast Ethernet dongle, and then you can use our portal and also the communication with MyPV. Yeah, at the end of the day, we also have AFCI in our inverter, and for the three-phase version, also PID recovering. And our inverter can also operate with our optimizer. This is very important. Yeah, and what's also important is our own battery. So since nearly 1 year, we are have our own battery on the market. So we have two main components for our battery. We have one power unit and one is the battery unit. And the battery unit have 5 kilowatt hours capacity. So, and you can easily add batteries on top of the other. So that means up to 50 kilowatt hours capacity on one battery. And then if this is not enough, you can also add a second battery in parallel without extra hardware. So it's a high voltage DC coupled solution, and the one battery is covering single phase and our three phase inverter. So you don't need an extra battery for the single phase version. You can see it also in the market. There are some competitors. They have a 48 volt battery for single phase or for three phase inverters, and then they have a high voltage for the other version. But with our solution, there is one battery can cover single phase and three phase inverter. Standard, it's stand floor installation, but optional, you can also have a wall mounted bracket, and then you can easily install the battery at the wall, IP66, and you can use our battery outdoor and also indoor. At the end of the day, we prefer indoor installation, but our battery protect himself. So also when you install it outdoor, we have some power limitations for higher temperature, and also we have a built-in heating system when you have minus degrees and you want to charge a battery. Then we are first preheat the system, the battery, and then we are starting charging the battery. We have 100% depth of discharge of the system, and we are providing 10 years warranty. On the right side, on the bottom, you can also see one nice graph how capacity and power fit together. So when you have a 5 kilowatt hour battery, you can charge and discharge with 2.5 k power. And when you have a larger battery like 10 kilowatt hour or 15 kilowatt hour, you can charge and discharge with 5k power. And when you need more power, then you can start with a 20 kilowatt hour battery. Then you have 10k charging and discharge power. Okay, and what is also important for the complete system, so we can also add optimizer to the system. So we have a complete MPP tracking, so maximum power point tracking. So we can use our inverter also without optimizer, but we have our own optimizer, then you can use it. You can use it partially, so that you have a string with 20 modules and only one optimizer to one module because you have shadow on one module, or you can use every module with optimizer, and then you have full optimizing solution. The communication is DC-M bus, so to the inverter, no wireless signal or something like that. And yeah, we have also module level monitoring, and when we shut down the inverter, then we have 0 volt. So to measure if every optimizer is installed correct, you can measure the impedance of the optimizer. Then it's 1 kilo ohm per optimizer. When you have 20 optimizer, then you have 20 kilo ohms. Yes. And what is very also important is our smart power sensor. Actually, we have 3 different versions. We have a single phase version for single phase grid, and then we have 2 different 3-phase versions. And we have CTs. So we have one CT with 100 amps and one bigger CT with up to 250 amps. And for normal residential systems, I prefer the 100 amp CT because it's smaller. And we are communicating over RS485 with the inverter. And with this information, MYPV can doing the power regulation. So they read information over Modbus TCP from our inverter, from in the end of the day, from the smart power sensor, and then they doing the control of the heater. And optional, we can also provide a backup box. So we have 2 different versions, B0 and B1. B0 is for single phase inverter and B1 is for 3-phase inverter. And with this backup box, we can provide backup power for critical loads. So it's also very interesting, and you can add it easy. Yeah, one important part is the dongle. So we have 2 different versions. I think the left side is the more important version. It's a smart dongle, WLAN, Wi-Fi, fast Ethernet. So you have Wi-Fi communication, or you can connect the cable on it. And Modbus TCP works on both communication direction. If you have Wi-Fi or cable, both works. And it work together with up to 10 devices. So you can build up a larger system also with this small inverters, and it's plug and play. It's a USB interface, and they transmit RS485 to Modbus in the end of the day. And the second version is a 4G dongle with 4G communication, but with this version you don't have Modbus TCP, and then you can't send information, or MYPV can't read information from the 4G dongle, so it's not possible. Yeah, and what is very important for Modbus TCP? So, for example, when you have a M1 inverter, like a three-phase 10K inverter, um, yeah, as usual, it's important to run the newest firmware on the inverter. For example, SPC 141 is the newest firmware, so you can easy update the firmware over the air over our portal. And then what is also very important that you have the newest firmware for the dongle, SPC 127, and then for the local, when you make the local commissioning, so our inverter needs to be commissioned over an app. So it's the Fusion Solar app. Normally, when you install the inverter and the dongle, you make the local commissioning, setting up the grid code, searching for the devices like optimizer, batteries, smart power sensors, and then you have also a setting to enable Modbus TCP communication locally. So this is important. Otherwise, the Modbus TCP port is blocked. But we have an extra document for that, and it's easy. It's only I think two or three steps to open Modbus TCP port, and then MyPV can easy read information from the inverter, like the feed-in power and so on. And yes, in the end of the day, you have the Fusion Solar app, so it's the local monitoring system and also for commissioning of the system and auto detection of the system equipment like optimizer and batteries, and also registration the plant to the portal, like scanning the QR code of the inverter. And then we have also our Fusion Solar portal, and you can use the app to read the information from the portal or use your web browser to easy monitoring the system, make over-the-air updates. Also, our servers use this interface when you have some issues with the system, and you can give our service the permission to check the system. And this is very important. And this is also what's very interesting when you are using Modbus TCP. Then the customer can use our Fusion Solar portal to monitoring the system, make over-the-air updates, and MyPV use Modbus TCP to read the information. When you are using Modbus RTU, you have to disconnect our dongle, and then it's not possible to monitoring our inverter or battery system. So that's why we prefer Modbus TCP for local communication. And here you can see an overview of our components. Yeah, from the left side, single phase inverter, and then we have three-phase inverter from 3 to 10K. When you build up a bigger system, you can also have a second or a third inverter. Up to 3 inverters work with batteries together. So that means you can build up a system with up to 90 kilowatt hour capacity. And yeah, very interesting is to add optimizer. And yeah, it's not necessary to use our optimizer, but when you need it, you can easily add it. And yeah, our own battery, optional the backup box, the dongle, very important device, smart power sensor, and in the end of the day, our app and monitoring system. And yeah, what is very interesting that we have our hybrid inverters, we have our own battery, and we have our own optimizer. And when you have some topics with the designing of the system, or for the commissioning, or afterwards when you have some service topics, you have one partner for all these topics, and this is very interesting. You have no service topics. No, it's the problem is on the battery side, or the problem is on the inverter side. You have one dedicated partner for that. So this is very interesting. And then together with MyPV, a very good system to store energy inside of the battery or you inside of your water tank. So this is very interesting.
Yeah, thank you, Dieter. And now it's about me to give you some more details about the potential to improve your system with the power to heat application. And one easy way to figure out what is possible for the optimization is this online calculator. It's called the MyPV Power Coach, and it's usable for everyone. So we do not require a registration or a login here. Here you can adjust your location, you can define a MyPV system, and you do the configuration of your project. Let's say it this way. PV power can be adjusted, hot water demand, volume of the tank, storage capacity of the battery, if there is a battery, even EVs can be considered. And what you get is an immediately calculation for the whole year, and the results for the self-utilization ratio and the independence ratio. You can also calculate the economics here, respectively operational costs, by setting a price for heat, a price for feed-in, a feed-in tariff, and a price for electricity purchase from the grid. So you can compare it in a technical way, and you can compare it in an economical way. You can compare 5 different variants here of your system, and it gives you an idea of the possibilities. So our clients, the customers we have together, they want to know what is possible. They want hard facts when we tell them about improvement potential. And this is the tool which provides this hard fact. So I really want to recommend it to you. Use it. It's free, and it's really an amazing tool to give an idea about the power to heat potentials in residential buildings. All right. There was the question in the chat. I want more info about MyPV and Huawei. So there is always the info center, respective to the download section on the MyPV website. When you enter Huawei there, you get the links to our manuals. You also get the result for the reference project description. And there is so much more you find there. For example, the wiring diagrams are there. This gives you the chance to pre-inform yourself. Even before you get your first unit with the delivery, you can check all the wiring diagrams here, and then you are perfectly prepared for your first installation. And this is all available for free, even without any registration. It's free for download for everyone. To sum up, MyPV is a manufacturing company. We offer power to heat solutions for residential buildings, and the power to heat principle is the easiest way to increase the self-utilization ratio. The perfect combination is the combination together with storage batteries. With Huawei, this is possible, and there are 2 solutions from MyPV which are called AC ELWA-E or ACHTHOR that can do so. In the meantime, there were a lot of questions, but most of them were sent just to the moderators, so unfortunately they were not visible for each one of you. One which was very interesting, which I want to mention once again, is the question if we can make the balance on all 3 phases simultaneously. This is something we cannot do. So the AC ELWA-E is a single phase unit. It makes the balance on 1 phase only. When we get the meter signal from the Huawei inverter, we make the balance of all 3 phases with focus on the calculation of the balance, but physically speaking, we are just taking the power of 1 of the 3 electric phases. This also applies for the ACHTHOR, which is a single phase solution as well, and for the ACHTHOR 9S, which is available to adjust the power output on each one of the 3 phases, but not simultaneously. So, question comes, how can we solve such projects? I know in countries like Finland or the Czech Republic, the balance on all three phases needs to be done simultaneously. And MYPV has already done such projects. To solve that, we use 3 single-phase actors, one on each phase. And in that way, we can make the balance on each phase. This requires special settings for the communication. The predefined standard is that we make the balance over the sum of all 3 phases. And yeah, for this kind of project, please talk to Talal, which is our international sales manager. He has already a lot of experiences with this special requirements of such countries. And this is the address where you get further info on the MYPV Huawei combination. Okay, if there is any feedback or inputs from your side, they are very welcome. Please enter them in the chat or reply to my email, which you're going to receive in a few minutes. At this point, I would like to thank you very much for your time and for your attention. Dieter, any final words from your side?
No, I'm fine. Thank you very much for this nice webinar and this nice platform. And yeah, finding solutions is a very important topic. And yes, what I'm learned today is that when you have when you need to find solutions, MYPV is a very good partner to go below the line and also have a solution for 3-phase unbalanced grids. And then, yeah, very good.
Thank you very much, Dieter. And for the team play today, I would like to say thank you to all of you, wherever you are. Stay healthy and have a nice day. Thank you very much.
Empowering the solar future.